Okay. Hello, everybody. So I'm Nathan Gauër, and I work on the HLSL to SPIR-V compiler at Google. And today I'm going to talk about HLSL 2020X, HLSL compilation in general using Clang, and also inline SPIR-V. So on the agenda today, we have, first I will go over HLSL issue that we have today and we are trying to fix. Then our roadmap, how to fix those actual issues, and then give you a little bit of an overview of where we are and what issue we are either we had faced or we are currently facing building this compiler HLSL to SPIR-V version, I don't know, third version. And finally, I will have a small timeline to just give you a rough estimate of when to expect new things to arrive. So HLSL today, let's start with the language level. HLSL has several issues. One is it's not specified. So when I started running this team, I spent most of the time looking at what compiler we're doing and also asking somebody at Microsoft, hey, this is legal or not, because it's not specified. And secondly, is development is quite opaque. So I just came in saying, how we got this new feature in Shadow Model 6.7. Can you implement that in SPIR-V? And sometimes it was, we won't implement that, like feedback buffers. And sometimes we have to deal with features that are a big mess compiler-wise. So, and so the lack of specification and also the closeness of the language development process is actually an issue because it doesn't help HLSL grow that much. Once we get the language issue, we also have the compiler issue. I will not talk about FXC. Sorry for people who still like this compiler. DXC is the new compiler for HLSL, but it's like a 10 years old fork of Clang. And because we did a lot of awful things to this compiler, we cannot backport a lot of new changes from upstream LLVM to DXC. So we are essentially stuck in 2017. And lastly, there is Microsoft handling HLSL to DXL side of things. And then there is a small team composed of Cassie, Steven, and I, who is trying to get a SPIR-V backend to continue living in that thing. So small team, small bandwidth. So if you had a new feature to ask, we were the bottleneck. That's also an issue we are trying to solve. And more specifically, the SPIR-V backend. For technical reasons, we decided to follow a different path from DXL generation. We take HLSL, we get an AST, and then we directly emit SPIR-V from this AST, which is quite different from what DXL is doing. And this leads to slight behavior differences. So sometimes we had diagnostic that Microsoft didn't have for DXL or the other way around. Then we rely heavily on SPIR-V tools. So what's happening is we get your HLSL, we go to a first version on SPIR-V, and then we feed that to SPIR-V opt to legalize it, optimize it, and then finally SPIR-V val. So if somebody in the chain goes wrong, you might end up with an error message saying, oh, this SPIR-V instruction is actually invalid. Please file a bug report. And you had no easy way to know, is that actually a bug report or just I'm doing something weird in HLSL that we didn't anticipate it. So bad user experience, also something that we need to address. And lastly, and that joins a bandwidth issue for the team, is if you wanted to develop a new extensions for SPIR-V, you needed to add this extension into the compiler. So SPIR-V tools, because we rely on that, but also DXC, which means if you're a vendor and want to develop something and bring it into HLSL, you had to either do it yourself in a compiler or ask us and wait a long time before we can get it to you. So with all this issue in mind, let's see how we can solve that. First thing, Microsoft is doing, I believe, a great job in trying to opening the language. So now the split the thing between the language specification and the development process of the compiler. So under the Microsoft CLA, there is this HLSL spec repository you can go contribute to and add new proposal for the language. So if you got a cool idea, something you want to integrate, feel free to drop a proposal. And there is a process, there is a working group under Microsoft CLA to just try to get that through. And then on the side, under the LLVM umbrella, there is an implementation working group, so WG HLSL. And the thing is, okay, we got a spec, now let's see how to implement that into the compiler. The process is new, And I know some people are a bit mad at it because of buffer pointer first proposal, which took between 4 to 8 months to get accepted, which is a long, long time. So yeah, process is being refined. Next thing that we actually had to go through with is cooperative matrices, so exposing this extension into HLSL, and the whole process for this proposal took 1.5 months, which is still a bit long, but way faster than like the old one. Side notes is the design phase is LLVM, but the HLSL language specification is under Microsoft CLA. So for big companies that can raise IP questions, yeah, just ask Microsoft for details about that. And last but most important is HLSL was not specified. So now we want to specify the language. And what's happening is every time a new feature is built into Clang, first it goes through HLSL spec. It's getting specified, then work group HLSL to design it, and then we put it to Clang, which means we still have a huge backlog, but language is starting to get specified. So it will be less of a compiler is the spec. And that brings us to HLSL 2020X. Because compiler was a specification, if a compiler had a bug, sometimes it was, okay, this is a bug, let's fix it. But sometimes, oh, so many people rely on that, we have to deal with that. And as we move to Clang, it's a good occasion to just try to start fresh and solve this kind of issue. So HLSL 2020X will be the last HLSL version supported in DirectX Shadow compiler and the first version supported in Clang. And the idea is if you move to HLSL 2020X, you will have some slightly things to fix, but then the move to Clang will be easier. So as an example, for function overloads, if you use a dot intrinsics in HLSL with a double, the only version that exists is half and float. So if you use a double, DXC is like, okay, fine, it just give you one, FXC another one. And in Clang will be like, okay, we don't know how to solve that, so please tell us between half and float. So this kind of little bit of details that they are trying to fix with this new language version. As for us, because we are definitely focusing on HLSL to SPIR-V, we aim to support Vulkan 1.2 and later. We started with that. We don't have a strong, how to say, Vulkan 1.1 would be okay to support. Just we need to start somewhere, so we start with that. And thanks to the great talk you had yesterday, you also understand why we need maximal convergence. So we will require this extension as well as variable pointers. And that would be super convenient if we want to bring references to HLSL language, which would be actually a good feature to have. And last bit is, as we said, small SPIR-V team. We need, every time you need an extension, you need to have somebody on a compiler maintainer trying to build a feature, right? So in the future, we are trying to give you a way to develop extension using inline SPIR-V. So the idea is operative matrices. You want to implement that to face that in a language. How does it work? You go to HLSL spec. You do a proposal saying how you want this to behave in a language, so the language stay healthy. And then you can implement that as a header, just pure HLSL header. And we are trying to use that to bring new extension to Clang. So the first one that was developed like that is actually cooperative matrices. Steven implemented that. If you look at the link, the header lives into the DirectX Shadow compiler repository. It's just there for the moment because we needed to put that somewhere, and we're still trying to figure out how to actually ship those headers. But those are pure HLSL headers. So it's supposed to be compatible with Clang in the future. Other thing, if you work with DXC, you might have noticed that when you compile HLSL to SPIR-V, you need to first select the Vulkan version, but then also the shadow model version. And that's just something that we had inherited, and that's super weird because some feature gating in DXC were depending of shadow model, which is DirectX, but no link with Vulkan. And you could end up in a case where, oh, you're doing some wave intrinsic operation, but targeting Vulkan 1.0, and we're like, yeah. So as we move to Clang, you still have this compatibility mode for DXC. So if you have a huge command line, you can use that with Clang. but there is also the new path that completely drops the shadow model when targeting Vulkan, because let's stop doing that. Other thing, extension. In DXC, we supported an extension. And if you build something, by default, you assume you can use every extension we support. So let's say you're writing something in HLSL and accidentally you do ray tracing. I don't know how you do that, but accidentally you do that. We will use in the module the ray tracing extension. And for you, the only way you had to say, oh, actually, I'm targeting a device which doesn't support ray tracing, you had to list all the extension manually that you allow to support. So that's a big laundry list on some devices. To make that useful, we want to use some kind of Vulkan profile. It's still not completely defined how in practically, in reality that will happen. But the goal is I want to target a baseline Android 15 device. So Android 15 device will say minimum are this set of extension. So compiler will only allow this set of extension. So if you use a feature in HLSL, ray tracing, and somehow Android 15 doesn't support it, then compiler will be able to yell at you saying, oh, you're doing something that I cannot compile, instead of just generating a shadow that you wouldn't be able to use. Obviously, we will keep manual flags to allow some extension or deny some extension if you need a workaround or something specific. But we want to have this faster pass. Okay, so that's the theory. And now where are we with that? I'm sorry to tell you, we are a bit far from production-ready compiler. On the Microsoft side, for HLSL to DXL, you can compile a trivial compute shader and read-write buffer resources. So it means you can load for read-write buffer, do some condition computation, and then output to it. On the SPIR-V side, we are nearly there. We have the same thing with condition, variables, and so on, but we don't have read-write buffer support yet. A few PR are coming, so it's just like a matter of weeks, but that's happening. Other resource and shadow types are not supported yet, so no pixel shader in Clang, no vertex shader, no read-write structure buffer. Everything is still getting progress. We have language-specified working group HLSL proposals are getting reviewed as we speak, so things are moving. And why are we that slow, actually? Challenge is building SPIR-V from LLVM-IR. So first big challenges that we had was structurizing the LLVM-IR. I mentioned that in DXC, we go from the AST to SPIR-V. And one of the reasons it's super easy to add up selection merge, up loop merge instruction to get a structural control flow. With LLVM-IR, you can do whatever you want. Graph can be irreducible. You can have go-tos, things like that. So we need to structurize this. I don't want to give you false hope. If you are doing a DOF device, we will still not compile it. But at least this time we won't crash. We just say you are doing something irreducible and don't do a DOF device, please. But if you get a normal control flow, we can now compile it to SPIR-V. For one interesting, we're using convergence intrinsics in LLVM-IR. So HLSL frontend needs to emit that, but if you get another frontend that correctly emits those convergence intrinsics, then it should be able to work with SPIR-V. Once again, I haven't tried that, so don't take my word for it, but try it. Other thing is, in HLSL, when you get a global variable and a local variable, those are supposed to be in the same address space. So if you get a pointer to one, it can be a pointer to the other one. In SPIR-V, graphical SPIR-V, we get storage classes and we get either private or function storage class, and these are not compatible. So initially we wanted to, on the HLSL side, put them in different address spaces, but that's still not completely agreed upon. It might change, but for now, decision from Microsoft was don't do that. So we do another thing is all local function variables are moved to the global scope. And that's actually okay because you are not allowed to do static recursion, which means we know how many variables you will use. This brings one big limit is the maximum number of variables you will be able to get in your shadow model is 65K instead of 500K. But that doesn't mean you cannot have more than 65K HLSL variable because an HLSL variable doesn't always translate to a SPIR-V variable, sometimes just a necessary register. So it's a limit. We're aware of this. We might have solution to go around this one, but it's not that easy to reach. And all these kind of hacks are required because we want to support clean linkage. So in HLSL, you have the export keyword. Linkage semantic for HLSL is not well specified. Once again, it's HLSL, but getting there. But the idea is you want to be able to compile a library of HLSL function and then link that later on. Okay. Yes. Oh, that was super fast. Stress is magical. All right, so timeline. Microsoft published a timeline last year saying what they want to do at some point. And the date for the first release to a full HLSL to SPIR-V compiler using Clang was December. We are not convinced this is going to be a realistic timeline, and they are not either. So yes, but this should tell you we are not hoping that this will come in 10 years. The goal is really we want to ship that as soon as possible. So today, trivial compute shaders, we are getting resources ready. Then we need to have semantic input and output for shaders, and that should bring us into the summer with pixel and vertex shader support. Once again, if everything goes well, because challenges, we get new ones every week, and sometimes like, oh, we didn't thought about that. And yes, so thank you. I want to take Anne's question. I guess he's not here, but for this blog, oh yes, your blog posts around.
Maybe I can do this louder. So I got one question, and sorry, this is a bit provocative. What is the original motivation for this work? Why are you retrofitting a specification for a language? Thank you.
So why are you doing this work and retrofitting the specification for HLSL when I currently look around and then the next talk is going to be about slang? Why aren't you using slang instead to compile HLSL to SPIR-V? Because I think that's working today. And so my question is, why are you throwing good money after bad money in a way?
So good question. First, what I will say is what I think. Like, I'm not a high VP, so strategy is not my thing. You got a language that is heavily used in the industry, and a lot of people are using that, know how to use it, and you can do, okay, we got this brand new language. Even you could say Wigzell. Why not moving to Wigzell? It's well specified. So, but sometimes you're like, okay, it's not the perfect solution, but everybody for now is fine with that. So let's try to fix our mistakes and move on. And that's mostly what I can say.
Thank you.
I don't know. Yes.
So 2 things to say. I'm sorry for flooding your repository with issues.
But
and thank you for your service.
So,
and the question is, if we get a Clang release, does that mean that we get, let's say, stuff like precompiled headers on day 1? And the follow-up, which is, do I pass the Vulkan profile as a JSON on the command line? And if so, how does that interact with the fact that I might want to say compile different entry points with different capabilities?
Yes. So that reminds me of a question you asked on Discord, actually. So right now, if you compile a shader as a like SPIR-V library, you can have multiple entry points, but the capabilities are module-wide. So if one entry point needs ray tracing, then you got ray tracing capability, and there is no easy way to just say this entry point is the only one that needs ray tracing capability. So until we fix that on the SPIR-V side, then I guess on the compiler side, we're just emitting capabilities for the per entry point capabilities and constraints. For target profiles, we are still trying to determine what is the correct way to do that. So if it's a JSON file that we give, if it just in a compiler, we have a bunch of strings that match its profile that we know about, and then we add them by bits, it's still up in the air. If you go to WG HLSL and you have a cool idea to suggest how to implement that correctly, please send a proposal. because yeah, the main thing I want to bring with that talk is there are open forums now. So please, if you got pain points, if you got things that you are like, I want that in HLSL, I want that in the compiler to change, just send an issue, send a proposal, something, so we can like start the discussion and have something like cool. And sorry, I forgot. Sorry? Yes, precompiled headers. The thing is, linkage on the HLSL side is not specified. Chris is aware of that. And this means, depending on how you want to implement that, we don't know. Sorry. We want to have headers, text headers, that's for sure. Precompiled headers, I'm not sure, because...
But I mean, PCH is basically AS being dumped to a file, and not getting file, so... Or, I'm wrong.
For that question, I'm sorry. I'm not sure I would know. Maybe you can ping Chris and ask, do they have plan for that? Because often when we ask like, hey, we want to do that in HLSL and go further, they're like, wait, slow down. We are not there yet. And yeah, sorry.
So I remember that last year, Microsoft announced that they are going to switch from the XIL to SPIR-V for their X. So is that related to the Clang, and how is the thing going on here?
Yeah. Yes. So right now they're contributing to two sides. One is a DXL backend, and they're also helping contribute to the SPIR-V backend. Because they do have plan to target SPIR-V in the end, which is a great thing because now they are thinking like how to implement that HLSL thing in SPIR-V, which is great for us. Now for their plan long term, as do they want to completely drop DXL to go to SPIR-V or something like that? Microsoft will be the best person to answer. Yeah. Question over here.
Hi, kind of a continuation from that question. So now that Microsoft are adopting SPIR-V as the intermediate language, to what extent are you getting support from them and help to speed up the roadmap?
Yes. So first, we're getting help because they communicate with us before doing something on the HLSL side. So we are not like, how the hell are we going to implement that? And secondly, they are actually contributing to the backend. So a lot of mass interesting things like that, which are, a lot of busy work to do. It's very important, but it's a lot of small PRs, and they are contributing heavily on that. And we're also trying to share as much things as we can between the DXL and SPIR-V backends. So even on the front end, we are not emitting something completely different. So they are really helping to get the SPIR-V backend out too. Yeah.
Thanks.
So I'm going to ask another controversial question, the opposite one, actually. You have...
Sorry.
Yeah, I'm here. So you're building a Clang backend that can do SPIR-V effectively.
Yeah.
And you're also modifying Clang, so instead of compiling C++, it compiles HLSL.
Yeah.
Why? Why do you not just stick to C++ at this point? Isn't that already where you want to be in the long term with templates and the rest of it? Don't you just want to make HLSL a library like HLSL API and then it's just C++ for the rest of it?
So cool C++ things would be nice to have in HLSL. Sadly, HLSL is not ready at all. So definitely the move to Clang is to allow sharing way more things with C++ and bring C++ features into the language. But C++ was made for CPU, HLSL for GPU, and we might still, even if we adopt a lot more C++ features, have things that are not that useful on the compiler side, on GPU side. So we are not trying to move too far away from C++. We are not trying to hack it completely horrendously. But yeah. Yes, so that was the C++ part, sorry. Did I answer everything or?
Yeah, so the question is more addressed to the HLSL. It's more a plea to the HLSL people is please just make it a C++ subset or superset or whatever it is. Like, Yeah, this shading language should just be a library, is my point.
Direction we are trying to move to. Like.
So any more questions from anybody? Okay, we could just thank the speaker again.